A warm greetings from Rohini College of Engineering and Technology video lecture series. I am Professor Radhika from Chemistry Department. In this previous video, we discussed about the important terms involved in the phase rule. Now we discuss about one component system. After completion of this topic, students can able to explain the importance of phase diagrams in the field of material science and engineering. Now we move to one component system. So the best example of one component system is a water system. Water system. We know that water exists in three possible phases, namely solid phase, liquid phase and vapor phase. Here all the three forms exist in an equilibrium state. Solid equilibrium with liquid, liquid equilibrium with vapor and vapor equilibrium with solid. Each of the above equilibrium involves two phases. Therefore, the phase diagram for the water system contains curves, areas and triple points. It consists of curve. This is a phase diagram of water system. It consists of the curve OA, vapor pressure curve, OB, sublimation curve, OC, melting curve. Let we discuss the individually the curves, components, that is areas and triple point. Curve OA is called as a vapor pressure curve. It represents the equilibrium between water and vapor. At any point along the curve, the equilibrium exists between water and water vapor. Here, the degree of freedom of the system is 1, that is univariant. Therefore, by using phase rule, F is equal to C minus P plus 2. When we put the values of C and P, we get degree of freedom is equal to 1. This equilibrium will extend up to the critical temperature 374 degree centigrade. Beyond the critical temperature, the equilibrium will disappear, only water vapor will exist. Then curve OB. Curve OB is called as a sublimation curve. It represents the equilibrium between ice and vapor. At any point along the curve, the equilibrium exists between ice and vapor. Applying phase rule equation, F is equal to C minus P plus 2. Put the values of C and P, we get F is equal to 1. The equilibrium extend up to the absolute 0 minus 273 degrees centigrade. Here only ice exists at this temperature. Then curve OC is called as a melting point curve of ice. It represents the equilibrium between ice and vapor. Along this curve, the equilibrium exists between ice and water. The curve OC is slightly inclined to the pressure axis, which indicates that the melting point of ice decreases with increases of pressure. Then point O. The three curves, curve OA, OB and OC, meet at a point O. Here, the three phases, namely solid, liquid and vapor, are simultaneously exist in the equilibrium state. This point is called as a triple point. At this point, the equilibrium exists between ice equilibrium with water, water equilibrium with vapor. Therefore, the degree of freedom F is equal to C minus P plus 2. Put the values of C and P, we get F is equal to 0, non-variant. At this point, the temperature exists is 0.0075 degrees centigrade and the pressure value is 4.58 millimeter. Then curve OB dash. Curve OB dash is called as a vapor pressure curve of supercooled water or metastable equilibrium. Here, the equilibrium exists between supercooled water and vapor. Sometimes water can be cool below 0 degree centigrade without formation of ice. This water is called as a supercooled water. This water is unstable. When it is subjected to a slight disturbance, it is automatically converted into ice. Then areas. This phase diagram of water system consists of areas AOC, BOC, AOB, which represents the water, ice and vapor respectively. That is, the area AOC represents water, BOC represents ice, AOB represents vapor. In order to define the system at any point in the area, it is essential to specify both temperature and pressure. Therefore, the degree of freedom of the system is 2 bivariant along these areas. When we put the values of C and P, we get F values equal to 2. So, okay students, in the coming videos we will discuss the other topics. Thank you.